Yeah. So, hello. Welcome to the Android Dagger therapy session. I already introduced myself, so that's enough about me. It's time for a story. Let's meet Josh here, or Harold, or whatever you want to call him. But don't worry if you don't like stories. I'm totally going to forget to do the story perspective within like 4 slides. So, Josh here, he decided he wanted to write an app, and then he published it, and then he maintained it for a long time, and then it got ugly. Oh, and my animation stopped working. But his app became spaghetti. Yeah, what is up with these? They're totally not animating to the presenter. Oh, there it goes. Okay, cool. So yeah, he got tired of his spaghetti app, and he decided he wanted to write it from scratch because Greenfield is really fun. He's going to do it right this time, though. Well, at least it's going to be better. It's just less spaghetti. That's the main goal. That's a mangrove. So Josh really likes separation concerns. It's a nice common buzzword we hear. But that's pretty cool. Version control, yeah, that all sounds great. So he's going to use Dagger. That's totally their official image, I think. Actually, no. I just drew that with Hangouts, and it was pretty cool. So they don't have an official image for Dagger, but, Google, you're welcome. You can use that. So Dagger, it's a dependency injection framework. Android developers here probably have heard of it. It's pretty common, pretty popular. It's got some advantages over the standard Java dependency injection frameworks. It's pretty lightweight. It was built with mobile in mind. The 2 favorite things that I like about it is it allows for reusability of elements of your application, and it makes testing a whole lot easier. But I'm not going to be talking about testing today, sorry. So back to the story. Josh is going to start his new application. So opens up Android Studio, does the whole new app, new main activity, all that fun stuff. Creates a new application class because that's pretty popular. And by the way, that little Kotlin box is checked, so everything here is going to be in Kotlin just because it's fun. Actually, it's really nice for presenting with Kotlin because it's so much more concise. So just helps fit the code on the screen. But yeah, it's time to add Dagger to this activity now. So he goes into his Gradle build file. He adds in the couple dependencies that he saw on the Dagger website. And he remembers to add the plugin at the top as well, because without that, it won't connect anything together and Dagger won't work. The cat plugin. Then he goes into his application class that he created for his application, and he adds a component. He could define it right there alongside it if it's Kotlin, but decides to put it in a new class. So he creates a component, and then he references that component inside his application. You notice that the component is pretty simply named Mangrove component there, but the class that he's referencing inside of his application is called Dagger Mangrove component. This is generated by Dagger after a quick compile, and it's used to actually get an instance of that interface. So don't have to actually implement it. So what is a component? That's a picture of component cables and has nothing to do with what a component is. But component is, so if we think of like Dagger 1 days, everyone was talking about the object graph. And the object graph being a tree, or a directed acyclic graph of Dagger, yeah, of objects and their relations and dependencies and how to provide them for injection. So component is one half of this object graph concept from Dagger. Still Dagger 2 now, but the component will help you define your relationships throughout the graph, throughout the tree, how they're connected together, and it helps define where you're going to inject things to. Notably, it does not define how to create things. So hey, look, it's a tree. If we think of this application component that we just created, the mangrove component, we consider that the root node of this tree, essentially. So far, that's all we have. But you can have other children to that and children of their children. And the important thing to remember here is how inheritance works amongst this tree. Things that the parent component provides are inherited to the children, but the parent doesn't know about the children. As in, child can inject parent things, but parent can't inject child things. And excuse the really beautiful graphic here. That was just standard Keynote components because I was lazy. So going back to the component, we're going to actually add a little bit of flavor to this interface now. He decides he wants to inject into his activity or his application class that we were using it in earlier. So all you have to do is add this little function definition inside of your component, giving it the target of the application. And then be sure to call that method inside of the application itself when we create the component. So back here on create, we grab the reference of the component that was provided by the Kotlin lazy definition, and then just call that inject method, supplying the application itself. Pretty easy. Since we define it in the application, the generated implementation of the component will also have that method, because it needs to. So next, we're going to add some little flavor here. Component that injects nothing isn't really useful. So modules are how we're going to do that. We can create a mangrove module and reference it in our component under the module's parameter of the component annotation that was used on the mangrove component. Pretty simple, pretty easy, and it's just a dumb implementation of a class that does nothing right now. So what is this module? Well, this is the other half of the object graph that we were talking about before. This is the half that defines how to generate our objects, how those instances will be created, but has no knowledge of the actual graph and relationships and parenting itself. Well, not yet, but maybe. And that on the right is a Raspberry Pi module of a night vision camera. I was just Googling module images. So providing these dependencies. So we need to have objects to actually provide from our modules. So say we need this API key string, just create a method. Methods, whatever you want, honestly. Common syntax is prefixing it provide and the name of whatever you're kind of supplying. But the most important thing is that the method has the return type of the object you want to return and has an annotation of @provides on the method. And this is Kotlin assignment for a method implementation, but trust me, that's a method. Next, we have to define that parameter where we want it injected to. So back in the application, oh, actually, did I? Yeah, I switched the variable names there. That's kind of cool. Now it's called something different. But now in the application, we define a string, and we give it the @inject annotation. Really, that's the only thing that Dagger needs to know in order to supply that object into this application. Even though I'm not calling it the same name, it actually still would work. It knows that it's a string, and it knows that it can inject strings, so it injects that string there during the injection on create. Also, just a little Kotlin note here too. We're using latent var here because the string is not nullable, but we're not actually assigning it at the initially. So latent is just a way to cheat the Kotlin compiler and say, hey, I know it's not assigned right now, but I guarantee it will be by the time I use it. It's handy here. So as you might have noticed, I changed the name of that string there, and it might have not been the string I wanted to supply to my injection. So I'll go back and I add another provider in my module for the string I actually wanted to have. So I provide a cache file name string, but now we might have a little bit of an issue here because now which one is it going to get? Well, it's not going to get any, it's just going to crash. It'll give you this kind of little error that string is bound multiple times, and that, actually I think that happens at compile time, yeah. And so, hey, you probably should fix that because we don't know which one to supply. So we fix this with qualifiers. What is a qualifier? Well, it's just a way of providing uniqueness to a provision. It's pretty simple stuff. Qualifier just has a name, and most commonly we use it on simple primitive types like strings, but you should use it for anything that you have to use it for anything that's provided, any type that's provided multiple times. It's another mangrove. So how do we use a qualifier then? So, well, first we'll define a qualifier here. we're going to find one for each type of string because we'd rather have clarity about which type of string we're injecting. So the qualifier can describe the object that we're injecting. We'll have a qualifier for our cache file, and we'll have a qualifier for our API key. These will both be applied to our strings, but it doesn't really matter what type they're applied to. It's just going to help clarify that type's detail. And then inside of our module, we're going to add those qualifiers as annotations to the providers. Just another annotation right alongside provides. Pretty simple. And then one last thing, inside of the application where we're injecting that string, we need to choose which type of string we're injecting. So we again add the same qualifier. Now the generated code knows what to do and everything works great. The end. Oh no, plenty more. So another thing I want to talk about here is modules referencing other modules. This is similar to how you would think of like when I'm talking about an object graph and dependencies and parenting and all that, but in one sense it's completely different. Modules can reference other modules, but it's not the same as like a parent to child relationship. There's no tree. They're literally just merging all the providers back in. So Mangrove module would have access to everything in data module here, and vice versa. So then we'll go on to dependencies. Sometimes your dependencies have their own dependencies. Like how do we create a shared preferences object in Android? Well, we need to use context, and context wouldn't be immediately available to this module class. So we define the provider saying that, hey, I need a context, and then I can create this shared preferences object. This works just fine if context is provided somewhere in the object graph, somewhere in the scope of our component. But currently we don't have that. So again, this would crash because context is not available. And context is one of those weird things in Android that you can't just create your own context. So this presents a bit of a unique situation of how do we get the context we want into this module provider without actually, caching your application context in a singleton and entirely breaking the whole point of dependency injection. Well, in our component, we actually have some pretty cool tools for helping with this. So back when in the first slide in the application, I was talking about how Dagger generated code. You just call it create and it generates your component implementation. Well, technically it's using a builder pattern under the hood. It's going to generate a builder for all your components. You could also define your builder manually, just like this. So we're going to do that here, and then we're going to add a little bit of functionality to it. So we create another interface. Generally, you just nest it inside of the component itself. We're going to annotate it component.builder this time. We're calling it builder. That helps. The most important thing is that it has the function at the end called function at the end that returns the component itself. The name isn't relevant, but typical builder pattern, you call build to build the item you're building. So we'll do that, but you can rename it if you wanted. And then we're also going to add a little method here to supply the context that we needed. So, and then we annotate this method binds instance. This tells Dagger to automatically generate a provider of that object to the graph. And it has to take the argument of what it's providing. So essentially, it's just like another provider that would exist, but you don't need to have it at the time of writing that module class. And then lastly, back when we were creating the Dagger Android, or calling Dagger, oh, that's the wrong name. I mix my code a lot. Calling Dagger component builder, call the app context method, we can supply the context. You could just supply this in Android if you're in the application class, but also has application context, and it all works. It's time for mangrove breaks. This is also kind of a halfway point. So moving along. So far we've talked about how to provide objects and how to create a component, but and I keep referencing the object graph, but really it's just one item thing. It's just the parent node so far. So how do we get our children and extend this graph? We use subcomponents. Pretty similar definition to components, just using the subcomponent annotation instead. So what exactly is this? Well, as I said, it's how we extend the object graph of the parent component. So anything annotated with a subcomponent is assumed to have a parent, but components themselves don't generally have a parent. But subcomponents will then inherit, well, depending on how you implement it, subcomponents should inherit the providers of their parent component. So like I was saying, depending on how you implement your subcomponents, the providing can go a few different ways, but I'm going to focus just on the most simple basic way today, or at least what I consider the simple basic way, which guarantees that all providers of parent component are available to the child. But you can definitely limit the scope of what the child can see of the parent, depending on how you implement this. So to do this, we're going to reference that subcomponent class through the module that's installed into the application component. So the parent component module references our subcomponent. It's an important kind of distinction to remember there. Otherwise, you might get mixed up between all your modules and components. So back here in our original application module, our mangrove module, we add another annotation parameter called subcomponents and supply the class user component that we created earlier. That's our subcomponent class. And then because we're doing it as this type of module subcomponents reference, you're actually required to define your builder right away. It won't generate that one for you, and it'll complain at compile time. Not entirely sure why, though, because it's able to generate them normally. But it's needed for some components that are connected this way. Not always necessary. Excuse me. So then we're going to go back to our user component. We're going to give it some teeth, just like the other component. We're going to give it a module. So now whatever this module provides is available to this subcomponent. Remember, nothing that this module provides will be available to the parent component. But the parent component's modules are available here. I'm kind of just reiterating now. So yeah, and then how do we use this subcomponent? Like, there's no visibility into it. With our parent component, there's a generated Dagger version of that component, which gave us access to the builder. Subcomponents don't exactly work that way. Again, caveat depending on how you implement it. But in this one, it won't generate your builder Dagger version for you. You have to somehow get access to that from your parent component. So because we reference the subcomponent as a subcomponent for the module of the parent, it actually creates a provider for that module, or for your subcomponent builder, technically. So we can expose the subcomponent builder just the same way we'd expose any parameter that's going to be injected from your parent component. I'm probably getting a little bit in the weeds of terminology here, but the important thing to see here is we're going to upgrade the application component and just expose the user component builder, our subcomponents builder, from the application component. I didn't really talk about this before, but this is another way of exposing injectable objects that are provided by your component. So you could do this for anything that like Mangrove module itself is providing. Just create a method that exposes that string, annotate it with qualifiers if you need. But we're going to do that here for the builder. I generally avoid exposing any other providers this way, just as a case of point, because it's kind of more flips instead of version control. You're more pulling your objects out of your component rather than receiving them. So that's just my preference. But anyways, so back in wherever we're using our user component, we get an access to the application class. Assuming like we're in an activity, you can grab the application. Then you grab the component off the application. You call that method for user component builder, then you build it. Then inject it wherever you need it. Pretty easy. Also, it's probably obvious here, but component on the application would probably be public if you want to do it that way, or create a getter or something. So take a little bit of a shift here. So far, everything we've done, whenever you inject it, it's going to be a brand new instance, or rather, it's going to call the provider method anew every single time you inject. But what if you want something to be reused? What if you have a stateful object that needs to be shared across some different areas every time you inject? Well, that's when you're going to use scopes. Has nothing to do with crest scope either. It was either that or gun scopes, and I didn't want to do that. So scopes, like I said, it's for reusing your injections. Without a scope, we'll be recreating a new object every time, most likely. But with the scope, it will persist your object and provide it again throughout injection, whenever it's injected again. It's important to note that the life cycle of the scope is bound to the component that provides the object. So if your component dies, obviously create a new component, it's going to create a new instance of your object that is scoped. This isn't some kind of overarching framework that manages Android itself. It's just an object that has access to providers. So your new object, it's going to have to recall those providers again. But because of this, you just have to be a little bit more careful with scopes because they are going to be thread safe. That also means it's going to be a little bit more slow. Just a little overhead there. So how are we going to use the scope? Well, Java provides us a scope automatically. It's part of the framework. There's a singleton scope. You can just use it. This is the source code of the singleton class. And this is also the only Java code in these slides. Important thing to note, though, is it's got that scope annotation. And that's really it. Well, retention is pretty important as well, but I'm not going to go into that. Yeah, we can just straight up use singleton scope. You don't even have to write your own. So yeah, back in our application component, at the root level, we have to annotate our component with that scope. And then if we wanted to, say, provide shared preferences only once and never have it recreated, we can annotate that singleton as well. This way, the first time that it's injected, this provide method will get called. The object will get cached inside of our component. And every other future time you inject it from the component, the same instance will be provided. And this provide method will no longer be called. And it's maybe seems weird that we have to annotate both the component and the module, but it kind of makes sense when you think about it enough that since the life cycle of your provided object is matching the life cycle of your component because it's cached inside your component, it needs to match the scope. Like, it's a way of clarifying that the scope I handle is the scope of anything with that matching scope. And I'm kind of repeating myself now, but like I said, you need to be careful with scopes. There's overhead. It's not that it's going to be really slowing your app down whenever you use a scope and you're going to see, 5-second load times or anything, nothing like that. But it is thread safe, so it's just going to be slower. And, maybe think a little bit more judiciously about whether you actually need them. Because sometimes, back like in the previous slide, I don't actually need to create or cache an instance of shared preferences. It's probably already doing that inside of the preference manager. But we can create our own scopes as well. And this is pretty fun because you don't want everything to have the same scope. After all, like maybe you have different life cycles, like activities inside your application that can come and go and die and be recreated. So maybe you want to have your own custom scope. So for here, we're going to make our own scope, just like the singleton, and port over the annotations that it was using and create our own annotation class. We're going to call this one user. And I dropped documentation, don't tell my boss. And then here, we can also create other scopes. This one is really handy. I know we've used a lot in the past. This is a an annotation class that takes a parameter. So the cool thing about this is that you can avoid recreating or creating new scopes every time you have a different type of scope in your activity or in your application. You can just have one scope that takes a parameter. And then anytime you need a new scope, send a different parameter. Here we're using an annotation called per, and it's receiving a parameter of a class. So whenever we want a new class scope or a new scope for a component, I like to just pass the component as that parameter to the per annotation scope, and then essentially saying user component class is my scope. Kind of dynamic scopes in a sense. You can also use this very helpfully with activities. So say we have a main activity, we can make a main component that's associated with it, use that per annotation, supply it the main component class. Now it's a completely new scope compared to the other per scope that received a different class. And then that's all the other boilerplate that I was already talking about. This is really handy when, for me at least, when I'm doing MVP, which is kind of the pattern I've used most often with my applications lately. In MVP, you have a view and you have a presenter, and I really like to define them to have a double-blind relationship where they know about the interface, they know about what methods are available on the opposite, but they don't know about the implementation class of each other. And Dagger can really help generate this in a way that they don't have to directly reference each other. Otherwise, you're just going to go into your view and create your presenter directly, and it's like, why bother? Because then the view owns the presenter, and you don't want that. So here we have a quick little example. I'm just creating an interface for my MVP contract inside of my main class or something. Oh, that'd be main contract, not contract. The presenter takes an argument of the view, and the view is just going to exist with its own methods or whatever. And then we have a little implementation of our presenter down here that doesn't do anything, but it implements that presenter from the contract. Then inside of our module for this main activity, MVP setup, we have two providers. One that provides the view, and the return type is main contract.view, and the other one that provides the presenter, main contract.presenter. And then they receive as arguments the actual implementations of those interfaces, but they're not presenting the actual implementations themselves, just presenting the interface. So it's more masking the implementation. And I should also note that this is a different type of module than I've talked about before. This is an abstract class version instead of an interface. Pretty similar. The nice thing about using an abstract class is you can use this binds method. So binds allows us to automatically have a binding between a parameter, a single parameter, and the return type. So as long as the parameter implements the return type, binds works for automatically generating your provider. It's a little bit faster. Pretty handy. If you're doing Java, you can do it static. Then back in the activity, we'll do the actual injection. So just like before with the user component, what we're going to do with this is the main component now. And on create, I get access to our activities component, our application component, sorry. Grab the builder off of that, build it, and then inject here. I didn't call inject either. Man, my slides are terrible. But so then it's going to inject the parameter at the top here, add inject presenter, which is just a reference to the implementation of the presenter, or to the contract of the presenter, not the actual implementation. And since we're, oh gosh, I even skipped that. Man, the slide's way off. So just like before with application, with the other activity example, you would then provide an instance of the activity under the builder, main component builder, above build method. Provide this as a binds instance version of the activity to the builder. And that would allow it to be accessible to this component here. Because otherwise, the provide view method wouldn't know where activity is coming from. So you have to provide it, just like before with the component builder. But yeah, I wish I'd fixed that slide. But it doesn't really matter because I wouldn't do that anymore anyways. Great that I talked about that all though. So there's some newer stuff in Dagger lately. I think it was added in as like, I don't know, 2.10. I think it started in 2.10. Some Android-specific tools that were added to help out with a lot of these kind of things. So we're going to use those new tools and try and solve these problems with them instead. We need to add these extra dependencies inside of our class. The support version if you're using support components, support library. Next, we're going to do a lot of refactoring here. So kind of ignore most of the manual stuff we've done before, but all the general framework is still there. We're going to take our application component, the Mangrove component, and we're going to add another module to the top here called Android Support Injection Module. This one is supplied by the dependencies from the Dagger dependencies that we just added. So it's not something you actually implement or ever really reference directly here. Next, inside of the of the application here, we're going to also implement an interface called hasActivityInjector. You just see at the top of here. And the only method there is the activity injector method that must return an activity injector. So we return that, but we also inject an activity injector into this application as well and return that instance. It's kind of roundabout, a little bit weird, but pretty easy to do. Next, we're going to update our subcomponents. So we're kind of killing the whole pattern we had before with the whole manually implemented or defined builder interface with all the build methods. Instead, we create a new builder inside of our subcomponent that's an abstract class this time, and it implements the Android injector builder. And this is going to be scoped for our class. Here I'm using an activity called launcher activity, so I'm having a launcher component and all that in a launcher module. So all the connections are pretty much the same, except for our component implements Android injector of the activity, and our builder implements Android injector.builder of the same activity. And then, and then we have to connect it all together through the parent module or the application module. So this can be done inside of your Mangrove module, or you can create a brand new module if you want. Since I like to do that, like make a new activity module or something like that, because all of the providers inside this module are just going to be references to activities inside an application. So here's our little syntax for it. Create a method that binds, binds the builder to the Android injector class. This is a little thing in Dagger called multi-injection or multi-binding. Sorry. This is available without Dagger Android components, but they leverage this tool to simplify this process. So what exactly is multi-binding? Well, multi-binding is when a provider has the annotation of into map or into set. And what that's doing is it's supplying that object into an injectable map or injectable set of objects of that type. So you can provide many objects to a single element. It's the way of collecting a lot of providers into a single object. Little refresher on map and set. Maps have keys, and that's how they retrieve their objects that are cached. Guarantee uniqueness on the key. Sets have uniqueness on the object. Just have one element or one parameter type, just the element, the elements, and they won't duplicate the elements inside the set. So depending on what type of set or type of grouping you're doing, you do one or the other. But in Dagger Android, we're going to use into map, and it will supply all the activities into the map. And then, finally, in our activity, we can clean up our messy code that I had of going and grabbing the application instance, grabbing the component's builder off of that component, subcomponent builder, and then calling build, and then calling inject. All that goes away. Now all you do is call the static method inject, Android injection.inject, and supplying your activity. And it's done. That's really all you need. We can adapt this for MVP pretty easily. The only thing of note was that when I was supplying the view, or supplying the presenter, I was requiring an instance of the view, or rather the activity, to create the presenter. So getting access to the activity inside of our module is still necessary, but it's already there. If you're setting up the modules this way with their implementing the activity injector, then you'll actually already have access to the activity that it's managing. If you need to provide other objects, you can kind of sneak around it in a way. Basically, like, say you want to inject the intent that the activity received when it started up. You can just expose that intent as a parameter, or it actually already is a publicly available getter on activity. So inside your module, when you're receiving the activity, you just return the objects that are publicly visible on that module. It's a way of supplying other objects to the presenter other than the activity itself. This could have been done without Dagger Android too, but it's just if you need more than the defaults, The reason we would do it all this way, by the way, is because you can't modify your builder in the Dagger Android pattern. So we can't do that sneaky trick of binds instance of the activity that sends a view. So it's still all possible, just you have to do a little bit of workaround tricks. And the last thing I'm going to talk about here is lifecycle. Android lifecycle is a pretty fun beast to tackle. I think most Android devs spend a significant portion of their development life fighting the lifecycle. It's a rather unique problem to Android since your activities will die and be recreated kind of at their whim. You're not really going to control that, and you should probably handle it. So if you have a component that lives on a lifecycle, that lives on an activity, that's a subcomponent and it's scoped to the activity, and so it's cached there. When your activity dies, your component dies. So maybe you didn't want that. Maybe you wanted to cache your component and have it work on the same activity throughout the application's life, but still be sub-scoped or subcomponent scoped to the activity and not be available everywhere. Well, you could persist it somewhere. You could persist it on the application. You could persist it elsewhere. But that can get really dangerous, especially if you're doing all the stuff I was doing before in the Dagger Android stuff of supplying the activity to your module and your component, because then you're caching activity. You don't want to cache the activity. You don't want to cache a context past the life cycle of that activity, because that'll cause leaks and that'll cause crashes. And I just did this whole slide without actually showing the slide. So mostly the thing to remember, though, is just be careful of managing lifecycle things like this when you're doing MVP, I guess. I haven't really seen this in any other patterns of supplying the context into your module, into your presenter and persisting it. So it's maybe one downside of MVP. But to solve this lifecycle issue without just caching a singleton or caching it on the activity or application class, there are some new features in one of the libraries made available by Google called architecture components. It has a lot of things in there, and I'm not going to talk about most of them. Only one I'm really referencing here is the lifecycle components, that are lifecycle aware components, I guess they're called. It adds a few new classes. There's a lifecycle owner and a lifecycle observer. They have a relationship, as you might expect, of observer monitors the owner. But lifecycle owner comes free now with your support activities and fragments, so it's pretty easy to use if you're already using support library. And lifecycle observer, you're never really going to manually create probably, but the key thing to know is just it's going to handle disconnecting from your the lifecycle owner when the lifecycle of like your activity or your fragment is ending. So if we were going to add this into our application from before, we would probably go and add these. Oh, why did I include persistence there? You don't need persistence. Just the first two, lifecycle extensions and lifecycle compiler. Persistence is for room. Don't need that. Next, we're going to use this new class that's provided from lifecycle architecture components called viewModel. Might sound familiar if you've ever done MVVM design patterns. It's model view, viewModel. It's going to work just like any viewModel would in MVVM, or at least conceptually. But instead of using a presenter, we're going to make a viewModel and extend that viewModel class. The parameter I've supplied to this class is nothing special. It's just a class that I would have generated of managing a user or something like that. Just showing you an example of receiving a parameter into your user model. And then it exposes some accessor to data that can be watched from the view. So then in our activity, we need to change a few things around here too. Because we're using, it needs a constructor. All my code's broken. Because we're using the new architecture components lifecycle stuff, we already have lifecycle from our support activity. So, but I didn't reference support activity, so that wouldn't be there. More code. But yeah, so suppose I did. We can inject a view model provider factory into our activity. This is a way of creating view models that, man, I did not look this code over well. Sorry about this. You can statically access a creator for your view models from the viewModelProviders.of method. That wouldn't work with our previous user view model because that user view model has an argument. So it's going to assume that you have a argument-less constructor. So this would break. Instead, what you can do is create your own implementation of the view model provider factory and inject that instead. And then use that to create your objects, supplying it the arguments as needed at runtime or at creation time. So it's really similar pattern to MVP in, by exposing, one to the other, but this way it's a little more direct object as well. So it's not like doing the double blind of a contract. So it's kind of your mileage may vary which one you like better. But the nice thing about this is it will be cached to the lifecycle thing and respond to lifecycle elements correctly, disconnecting from things when it needs to and cleaning itself up. Like I said before, it's probably just better to make your own implementation of the view model provider factory because very rarely are you going to use a view model that doesn't take any arguments. It'd be hard to get a lot of usage out of that. And last thing I'll say about the architecture components thing here is please do check out their sample code on this. It's really well done. They have a pretty good sample application as well for handling this stuff, but on their website, it's a lot cleaner code and not as broken as mine. So finally, let's review. Learned a lot of great stuff today, but hopefully this has been therapeutic. And that's it. Thank you.
Questions? Okay. Guess we can do that one.
Oh, cool. Let's do it.
Yeah, I'm going to stop the.
I'm going to stop sharing. Thank you all.